Tonight's guest is Dr. Ray Anderson. He is a retired geologist and vice president of the Cedar Valley Rocks and Mineral Society. And if you have not yet been upstairs, there is a collection of his meteorites that he personally owns in the glass cases on the second floor, along with some that were loaned to us through Ray from a variety of museums. So do go upstairs and take a look at the actual meteorites in the cases. I'm going to turn it over to Ray, and he can do the rest of the introductions, because I never know what to say other than, he's my next door neighbor. So.
I used to be right across the street from her. I did, but I moved. As Beth said, I worked for the Iowa Geological Survey for a number of years, and one of my jobs there was to identify rocks that people would bring in, and particularly people always brought meteorites, or meteor-wrongs, as I like to call them. But that got me pretty interested in meteorites, so before long I was kind of a local expert when anybody wanted to know anything about meteorites. So what I want to talk about today are basically 9 meteorites in Iowa's history. That include some that we saw fall, some that we have picked up off the ground, and just some big holes in the ground. And knew I was missing something. No. Oh. Thought I was going to beam somebody up here. First thing we'll get straight here is the little thing on definitions. What's the difference between a meteor and a meteorite? Well, this is a meteor flying through the atmosphere. Well, technically that's an airplane, but that's what a meteorite would look like flying through the atmosphere. When it lands on, or what a meteor looks like flying through the atmosphere, when it lands on the ground and you can go over and pick it up or at least touch it, that's a meteorite. So a meteor when it's flying through the air, and a meteorite when it's on the ground. Lots of us think of meteorites plunging through the atmosphere and blowing big holes in the ground like the meteor crater up here, for instance, or maybe destroying the whole Earth. That is possible. But most of the meteorites that we really interact with are little microscopic bits of dust. There's little bits of the primordial cloud that the solar system formed from, coming into the atmosphere and burning up and making little glass spheres. If you look at these under a microscope, you see they're kind of funny shaped things. And we get somewhere in the order of 11 million tons a year of this stuff falls on the Earth. So that's the equivalent of about a shoebox full per acre. So there's a lot of that stuff coming down, and over all of geologic time, that would have piled up to 150 feet deep. So there's a lot of little meteorite dust on top of everything around here. Comets are another thing that are related to meteorites by many people. Asteroids are another thing that's called meteorites. These are most common meteorites. Let's talk a little bit about comets. Comets fly through the air. They usually are illuminated by the sun with a big stream of light. There are 2 primary types of comets that we can find. There's a short period comets, and that's these that basically come from this place called the Kuiper Belt that is on the very outside of our solar system. As a matter of fact, Pluto is now considered a Kuiper Belt object. So that's all these things here. They get perturbed every once in a while and come around the sun and then go back out into their orbit. And those are very short period comets, are called, and those things might have come back more often than more than 2 or 3 times or something like that. Then there's the other comets, the long period comets. And those guys come from way, way out there in a cloud of particles of dust and snow that are kind of lumped up into little objects out there. And that's somewhere on the order of 6 trillion miles away. So that's way the heck out there. We estimate there's something like 200, or there's something like 6 trillion of those things, where the distance is here, 200 to 20,000 billion miles. So that they're way the heck out there. And there's trillions of these things. They come into the atmosphere every once in a while, but they usually only come in once. And as they get close to the sun, since they're made up primarily of snow and rock fragments, the snow melts and they leave a trail behind of comet dust. Now, if that trail happens to cross the orbit of the Earth, whenever the Earth comes by through that trail, we're going to get a lot of little meteorites, and that's what we call a meteor shower. What you normally see is just little streaks of light like this. There's particular times of the year that they are predictable when they're going to be going through this. You can go out and see those little streaks. Or once in a while, a little bigger particle might make a fireball. But that's about all those things do. Just make a little light in the sky. They don't do anything too serious. Asteroids, on the other hand, are rocks and solid and bigger. The bulk of the asteroids come from this area around that circles around the sun between the orbits of Mars and Jupiter. There's estimated to be something on the order of 150 million of these things that are bigger than 100 meters in diameter. It's 300 feet in diameter. So a lot of potential meteorites out there. Every once in a while, the gravity from Jupiter or a collision or something knocks these guys out of their orbit and they come in and loop around the sun. Well, when they do that, they can cross the orbit of these other planets, including the Earth, and they're called Earth-crossing asteroids. And if you think that there's somewhere on the order of 100 million of these things, now I forgot the number, I'm sorry. Anyway, there's lots of these things that are crossing the orbit of our planet, and so occasionally there's going to be collisions, and they are. And when they do collide, these are what we call the meteorites. So here's what asteroids look like. All different sizes and shapes, and when they get down to Earth, they can look like a lot of different rocks. And you know, these look an awful lot like a lot of rocks that are common to Iowa. Igneous, metamorphic rocks and sedimentary rocks that are brought down by the glaciers or actually formed in Iowa can look very much like this. So it's really difficult if you find a rock out there to know whether you have a meteorite or not. And that's where my job, or my compatriot at the Iowa Geological Survey, Ryan Clark, can do that now, can tell you whether it's a meteorite or not. We have three major classes of meteorites. The Stony meteorites are either chondrites or achondrites. Chondrites are just these little bitty pieces of material, little round marbles of material that have kind of formed from the cloud of gas and matter that made the solar system. They're still floating around out there. They kind of lump together. Achondrites were chondrites at one time, but they're partially melted, and so they've changed. Iron meteorites, another major class, and they go by a number of different names, primarily depending on how much iron or nickel they have in them. It'd be hexahydrites or octahydrites. And then the final class is mesositerites and palastites. These are what are called stony iron meteorites, kind of a combination of both, and frequently they're created when a stony meteorite smashes into an iron meteorite as they're orbiting in the asteroid belt, and they're combined to form one. Or sometimes you can get an area out of the middle of a meteorite that looks like that. So these are the major classes of meteorites. And we'll take a look at some of these a little closer. I talked about the chondrites, formed from chondrules, little pieces of primordial material that clump together in these clumps. And then these clumps, you can see them individually here, lumped together. Well, another thing that's lumped inside of there are these little white things here, and these are called CAIs, calcium aluminum inclusions. They're little things that actually precipitated from the gas before the little particles formed. And we're able to date those things. They're 4,560,000,000 years old, so they're the oldest things that we can find in the solar system, the oldest things related to the formation of our solar system. And you can find those. I have one of these, I have this rock, as a matter of fact, on display up there in the display case if you want to take a look at it and see what the oldest thing in the solar system is. Achondrites are stony meteorites, and they account for, I should have said one other thing about this back here. 86% of all of the meteorites that fall to Earth are chondrites. So they're pieces of primordial gas cloud that just never got together to form a planet. So that's the bulk of them. Now the achondrites, only 7% of all meteorites that are found are achondrites. So these are pieces of the chondrites that actually got together in a big enough group to actually form heat and melt and alter the chondrites. So they're achondrites. They're usually formed in association with iron meteorites. Whoops. Don't push that button. They're usually found in association with iron meteorites, They're formed in association with iron meteorites. That is, iron meteorites are about 6% of all the meteorites we find. And these meteorites are both formed in the same manner. All of those little pieces of chondritic material got together in such a big mass that they actually melded, just like they did on Earth. They melded. And the dense material went to the center, so you end up with an iron nickel core, and then a regular rock, a ferrosilicate mantle around the outside. So that's happened to many, many planets and many, many asteroids. And with all these asteroids in the asteroid belt, when they smash together like this and break apart, then you get iron meteorites, the center pieces of the core, and stony meteorites, the pieces of the mantle. So that's the main way that these meteorites form. Chondrites, if you'd find one in the field out, if you find one in a field in Iowa somewhere, for instance, it's going to look an awful lot like a lot of other rocks that you'll find in the field. This is another pretty typical rock that you can find in Iowa. It's an iron siderite concretion of Pennsylvanian age. You find it distributed all over the state. Looks a lot like it. This is why you need to talk to an expert if you want to be sure you've got one. Iron meteorites, they're usually fairly easy to spot, although there's a number of things that can be confused with it around here too. You can get iron oxide precipitates that form rocks that look like that. You can have iron formation coming down by the glaciers brought down from northern Minnesota where the iron mines are. All of these things can be confused with it. The largest meteorite that we know on Earth right now that actually is sitting there, you can go and see, is this one in Namibia called the HOMESTEAD meteorite. Big iron meteorite just sitting out there. They built a wall around it so nobody trucked it away or anything, but I think at 60 tons it'd be pretty tough to move. This is a typical iron meteorite. This is one that we find in Iowa, and iron meteorites, if you can cut and polish them, you can be really sure that they are a meteorite. This is that Alvord meteorite that's been cut in half and then polished, smooth, etched with nitol, which is a mixture of nitric acid and alcohol, and it brings out these lines. Now these lines are what we call Widmanstätten lines, named after this German guy, and they look like this. They're actually crystals of iron and nickel called camosite, and these crystals kind of grow in that planetoid that was in the asteroid belt was slowly cooling. As the core was cooling, these crystals can grow. It takes millions of years for these crystals to grow. We can't grow them here. So when you see this pattern on an etched meteorite, or an etched iron stone like that, you know it's a meteorite. So that's good proof. There are a few other unusual chondrites around too that you and I will never see probably. We estimate there's about 61,000 meteorites that have been found and collected on Earth. Of those, 224 of them are Martian meteorites or SNC meteorites. They're meteorites that were pieces of rock that were actually blasted off of Mars by a big meteor impact. There's a few more that have been blasted off the moon. We have about 306 of those out of the 61,000 that were actually pieces of the moon that are blasted off. And we know enough about the geology of the moon and Mars by the work we've done to be able to identify these as such. So those are pretty rare. You're not going to see those, but those would also be called chondrites because they originally formed and then were melded. Okay, we have information, we have actual chunks of meteorite, chunks of rock from 7 different locations in Iowa. These are called historic meteorites, and we've broken them into 2 classes here, the fines and the falls. The falls are ones that are actually observed falling, like the Amana meteorite, Marion, and these up here. The fines are ones that a farmer just happened to come across them in his field and guessed that's what they were, and yep, he was right. So we have 4 falls and 3 fines in Iowa history of the 7 meteorites that we know about from Iowa. 1999, I got all of these together for a display at our rock show and at the state fair. So here's what all of our Iowa meteorites look like. There's a dime for scale. I'm going to try to get these together again next year in March when we have our rock show up at Cedar Rapids, the big Cedar Rapids rock show at Hawkeye Downs. That's a show that we sponsor. And the theme is going to be meteorites. So there'll be a lot of good meteorite displays. I'm going to see if I can get every one of these ones from Iowa from the various museums they're at. They're at the Field Museum in Chicago. Some of them come from there. Some of them come from small local museums, and there's some of them that are out at the Smithsonian that I have to get from them. But we'll see if I can do it again, because they're really kind of neat. Okay, so the ones that we observed falling, the first one was in 1847, called the Marion meteorite, that followed that path there and crashed south of Marion. The Amana meteorite followed that path in 1875. Estherville meteorite came that way in 1879. And then finally, the Forest City meteorite flew in from the west in 1890. Those late 1800s was a good place for meteorites, huh? They're shooting at us. So we'll talk about these guys first, and I'd like to talk about the Marion meteorite. That's a pretty interesting one. It came in basically right across Iowa City like that, and crashed right on the side of, or on the banks of the Iowa River, right up here, sort of in the area where Bertram is today. It was observed coming down. It exploded before it landed, and then the pieces were observed falling by people that were actually out there in the forest. And a lot of people collected up these things. They looked at them and they saw they had little sparkles of silver in it, and they said, "This is silver." So they started breaking them up so that they could get the silver out. Well, that silver was really a piece of iron, because iron is common in meteorites, and they basically destroyed most of the good rocks. This thing flew over Iowa City on February 25th, 1874, which was a time when the Iowa legislature was in session. Iowa City was the state capital then, and the Iowa legislature was in session at that time. And that was the same day and almost the same time that Iowa's first governor, Ansel Briggs, was signing the declaration that formed the University of Iowa. So the University of Iowa was formed the same day that a meteorite flew over and crashed up in there. Well, we fortunately have the largest of those Marion meteorites is in the University of Iowa Museum, and we have it on display up here in the library on the second floor. You can want to take a look at it. That's the largest piece that survived. This is what it looks like, broken surface. It's a good chondrite made up of a lot of little spherules, and you can see that on a broken surface. The next meteorite was one of the biggest ones we had, seen by a lot of people, really studied, and lots of samples recovered. The Amana meteorite, sometimes called the HOMESTEAD meteorite. This was originally, wasn't seen originally, but it was researched way back right after the thing fell by a fellow named C.W. Irish, who was an engineer. And he's the guy that actually designed the sewer system for Iowa City, among other things. But he was an engineer. And he went around and he talked to a lot of people and got their stories and all their information. And then he published this as the first of 2 books called The Detonating Meteor. It's called The Detonating Meteor because when it went up, when it landed, just before it hit, it blew up like a lot of these things do in the atmosphere. When it blew up with a big bang, that the people of Iowa City thought that Marion had blown up. Marion was the big town up there at the time. That was before Cedar Rapids got so large. So it's called the Detonating Meteorite. And he had this map in there. It was a fold-out map with hand color on there. And you can almost see that, but if you zoom in a little close, we can highlight a few of the things. There's southeast Iowa, and the meteorite came in over Missouri, exploded, came in one more time, exploded kind of in the corner of Keokuk County there. And then the pieces from that explosion came raining down south or west of the town of Homestead, right up in there. But the biggest piece of this, as observed by people, flew over the Iowa River and exploded somewhere up in this area. So that's interesting to know. We have 2 areas here. Okay, this is a kind of a computerization of the map that he had. The red dots show all the places where the explosions of these things were seen, most the Missouri one, the Keokuk County one, and then the one up here on the north side of the Iowa River. Explosions were heard over this wide area, and then he talked with a lot of these people, and he was able to construct the route that this meteorite flew, and in his book he's actually made some nice woodcuts of what these people thought that the meteorite looked like. So there's some pretty prints of what the meteorite looked like according to the observers at the time. One of the more interesting places was up here at Dubuque. The Dubuque newspaper said the next day, a brilliant meteorite flashed through the heavens last night and appeared to strike the earth within the city limits. They thought it was it crashed up in here. That's how bright that thing was when it came down. So you can read the rest of it, but they thought that a meteorite fell just outside of the town limits of Dubuque, and so people actually went out looking for it, didn't find it. It was also seen in Rockford, Red Wing, Omaha, St. Louis, Chicago, St. Paul, long ways away, 260 miles away in St. Paul, they saw that flash explosion. This is another map out of Irish's book, and it shows the Amana strewn field here. These are all the individual spots where meteorites were found. And his idea of the directions that they might have come in. The two largest pieces were found on the north side of the Iowa River. All the rest of these were on the south side. And then this is where that biggest piece came over and exploded here in Benton County. And there's never been a meteorite found from up in there. But there's no reason to think that should be any different than this. So somewhere up in there, there should be a big strewn field. They found equivalent about 800 pounds or so, 150 to 200 fragments there in the Amana colonies. And this is where that exploded. I used his map and went out and took a picture of the field. It's just a nice soybean field at the time I was out there taking a picture. But the strewn field that exploded should be somewhere up in that area of Benton County. So I would say if you want to go find a meteorite, get your metal detector and go up there, because nobody's ever found one, and it has to be one, at least according to the observations. This other fellow came by a little later, a little shy-looking guy, Gustav Gottlieb Heinrichs. He was a chemist for the Iowa Geological Survey and worked at the University of Iowa. He got really interested in these meteorites, and he tried to document them even better. He went out and photographed as many as he could find, tracked them down, find out where they went, put together a pretty neat little compilation, actually, that showed where the various sizes of meteorites went, how big they were, what place they went, Copenhagen, Berlin, etc. So these were passed out and spread all over the place, and that was the best compilation at the time, Mr. Hendricks. The biggest one that's around, and this is the one that was found north of the river, is at the Amana Heritage Museum. I'd like to get a hold of that for the rock show next year. I'll see if I can. They lent it to me back in the 90s. Maybe they'll lend it to me again. Big one though, 74 pounds, worth several $100,000. Again, it's a chondrite made up of a lot of little pieces. And another interesting thing, I don't remember how many of you people, I don't know how many of you people ever saw the Meteorite Men when they were on TV. It was kind of a cable channel show, and these guys went around to different meteorite spots, and they tried to find meteorites and stuff, and it was a big deal. They came to the Amana colonies, and these are the two guys here. They brought their film crew along, and they went out with their metal detectors, and they detected things, and they found rocks, and they took their little gator product over here out into the swampy lowlands, because that's a place where there weren't any meteorites found, but the swampy material, you know. But the only meteorite they found was this one here, and this is that big one from the Amana Museum that they brought out so that they could test their metal detector and get it all calibrated. So never found anything, unfortunately. The next meteorite that came in is called the Estherville meteorite. Fell near the town of Estherville in 1879. That's had an interesting story too. This fella named Irish, you know, that wrote the report on the Amana meteorite, he was out doing some surveying up in southern Minnesota, up here on a railroad line, and this big storm came rolling out of nowhere. So he jumped on his wagon and he was hot-tailing it back for town. He looked over his shoulder and saw a meteorite fly out of this cloud, went past him and exploded to the south. So he went down there and chased it naturally, and followed the vapor trail right down to it, and they found what's called the Estherville strewn field. So these represent the spaces where all the meteorite pieces were found from the Estherville meteorite. Hundreds of them were found, and this was a prairie at the time. And so most of those little ones couldn't be found because they were buried into prairie grass, but every time they'd have a prairie fire out there, they'd go out and look for meteorites, and so quite a few of them were found. The biggest one landed right here in this little swampy area right there, 423 pounds. The next biggest one landed right over there, 151 pounds, and then finally on the end, 101 pound. Well, the biggest one got eventually recovered because they found it right away because it made a 12-foot diameter crater when it hit the ground. Didn't blow up, just blasted a big hole in the ground. So they crawled in there and they got that big meteorite out. And that guy went to the British Museum. And they have divvied it up all over the world since then. The middle-sized one got snagged by the Minnesota State Geologist and went up to Minnesota. The smallest one, 101 pounds, and that's not very small, probably that big around, disappeared. So they don't know where that showed up. It might have got cut up and distributed around to people, sold to different places. I don't know, but that one, we have no record of it. Well, this is what that meteorite looks like. This is a little different. This isn't a chondrite. This is a stony iron mesosiderite. So it's a mixture of a lot of different things. As a matter of fact, this is a thin section where you take and cut a slab of it and polish it, and you can see these little blebs of iron. This meteorite is famous because those blebs of iron are a type of iron that's called tetratonite, and this is the first time it was ever identified in this meteorite. So this mineral is named after this meteorite. It's just an iron nickel mineral. Finally, the Forest City meteorite was seen flying over in 1890, observed in a lot of different places around the state, including there in Grinnell, where there was a baseball game going on at the time, supposedly. And they could see that vapor trail coming from horizon to horizon, and everybody in the baseball game stopped and stared at it. So that's one of the stories that's told about it anyway. All of these meteorites have great stories. There we go. Here's the Forest City strewn field, a more or less a circular thing. And one of the biggest meteorite pieces that was there was again, that was recovered was again something that was of interest to the Minnesota Geological Survey. So the governor of Minnesota, as a matter of fact, told the state geologist to go down and get a big one of those meteorites. So he sent his buddy down after the largest of those, which was an 81-pounder. So the assistant state geologist, who was Horace Winchell here, came down and he made a deal with the guy that found that 81-pounder and gave him some money for it and was ready to take it off when the sheriff came up and they realized that he had actually found that on his neighbor's property. So it wasn't his to sell. So the neighbor took it, and right away Horace Winchell there said, you know, you can't have that. So the sheriff took it to the sheriff's department, and it was there in the sheriff's office. Meanwhile, Winchell got a lawyer and got some sort of a writ for the sheriff to release that meteorite to him. He took it under his arm, jumped on the next midnight train to Minneapolis, hauled it up to the University of Minnesota, and buried it into the ground under a storage shed. And that's where it sat for several years as it went through a lot of litigation and eventually ended up in the Iowa Supreme Court. And the property owner was the one that ended up getting the right to keep it. And he, in turn, sold it to the Minnesota Survey for about 5 times what it was originally sold for. But you can see that today up at the University of Minnesota if you want to go up and take a look at it. Here's what Forest City meteorite looks like. This is one that I got from the American Museum of Natural History in New York, and broken up. It's a nice chondrite too, just a lot of little pieces. You can see off this broken thing. The rest of it is covered with that kind of burnt skin, the crust that you see a lot of meteorites have when they fall from heating up in the atmosphere. Okay, the rest of these meteorites, the next three are finds, and we have three meteorites that were just found by farmers. One at Mapleton in 1939, Lone Tree in 1971, and then finally Alvord. There were two of them that were found up in this area by two neighbors in 1976 and 1981. Let's look at the oldest one first, the Mapleton one here. This is the Mapleton meteorite. It's a good iron meteorite. It's etched, has these beautiful Midmanstatten lines. And this piece of slab I borrowed from the Field Museum back then. And I'll try to get it again with these nice lines. You know it's a meteorite. You know it's iron. Weighed 108 pounds. That was found by this guy named Harvey Mears when he was plowing. And he hit this big rock, and it was big and it was heavy. And he said, this is just the thing to help me plow. And he put it on the back of his plow to keep it in the ground, you know. And he plowed with it all day. And then when he went back to his barn, he took it off and threw it in the barn and for later use, I guess, then went into the house. And it turns out that he'd just gotten a National Geographic that had an article about meteorites. And he looked at that, and he looked at his rock, and he said, I'll bet that's a meteorite. And sure enough, it was. And the Field Museum bought it, and there it is. Lone Tree meteorite found down in the floodplain along the river near Lone Tree, 1971. Again, this is a farmer that was plowing his field and hit a rock. Well, he's out there in the river sediment and the really fine-grained material, sand and silt, etc., and he's hitting a rock. He said, this isn't right. And he thought this was pretty weird, so he hauled it into the geology department at the University of Iowa, and one of the professors took a look at it and said, yep, that's a meteorite, and swung a deal to get it, and so it became the property of the University of Iowa. And he slabbed it into a number of slabs. It's really a pretty ugly meteorite. It was sitting apparently in these river materials for a long time, and it rusted pretty badly. But it's a chondrite again, but it's got enough iron in it that it's rusted and turned this ugly brown color. I have one of those upstairs too, if you want to go up and take a look at it. Not too impressive, but it was a pretty cool meteorite and one of very few that we found. The most recent ones were these up here in Lyon County, the Alvord meteorites. There were two of those. I knew about one of them that was found by this fella Herb Van Ingen in 1976. He was, again, I think he was cutting hay or something like that. I don't think he was plowing. And he found this rock, and he thought it was pretty unusual. Took it to the local museum. They passed it on, and it worked its way over to the Chicago Field Museum again, and they identified it as a meteorite. 38.5 pounds. They had it cut in half, and they kept one half, the Van Engens did, and the other half was in the museum there at Chicago. Oh no, I mean, sorry, in the Smithsonian. I mean, not the Chicago Museum. I forgot. Anyway, so the other half is in that museum, and this half apparently got sold somewhere along the line, because when I put that meteorite display together for the rock show back in '99, I only knew of one meteorite, and it wasn't this one. It was a different one. It was an Alvord meteorite, but somebody at the show had the other half of this, and so, boy, I found out, you know, there's more meteorites. So I found out a lot about this. I tried to call this fellow to talk with him. That was 10 years ago or so, and he had passed away, but I did get a chance to talk to his wife, and it was pretty interesting. She said that the neighbor found the other one, and that was Jim Kelly, and it was found in 1981. And she said that Herb was over there helping Jim out when they found that. And so I called up Jim Kelly, who was still around there at the farm at the time, which is pretty cool. I gave a talk similar to this up at Swisher a month or so ago, and Jim Kelly's son was in the audience. Got a chance to talk with him, Dave. That was pretty cool. This is what that meteorite looks like. Strangely enough, it's exactly the same weight as the other one, 38.5 pounds. A little different shape, but there were two of those found, and this one also ended up in the Smithsonian, sold for a pretty penny, I believe. So those are all the actual meteorites that have hit the ground in Iowa that we've recovered. That's all we know about now. There's plenty more of them out there, but they look just like every other Iowa rock that you've seen. So it's very confusing. So keep your eye. If you find something unusual out there, Might be a meteorite, you never know. But we have a couple other ones that I want to talk about. Oh, I'll mention this first. The State Historical Society, in their 1958 version of Palimpsest, the April version, had an article about some of these meteorites, written by a guy named Ben Hur Wilson from Illinois. And he wrote about the Amana, Forest City, Estherville, Marion, and Mapleton meteorites, including some of the stories that I told you, but a lot more. And if you're interested at all in these, I really suggest you take a look at that, and you can learn an awful lot. A lot of good stories. Every one of these has a really great story, if you believe it. I believe it. Okay, beside these 7 meteorites, we have 2 impact craters. These are actual holes in the ground that were blasted by meteorites. The Manson impact structure was the first of these discovered, and it's a big guy. It's out there in kind of west central Iowa. And then more recently, we found out that there's one right under the town of Decorah. So let's take a look at the Manson one and see what that tells us. This is an old Skylab picture taken in the days when these imagery went diagonal across the globe and they didn't rectify them, so everything looks a little crooked. But this is north up in this way here. And these are the counties, and I drew an approximate line around where the crater is. You can't see it today, but we know from studying water wells that are drilled in this area what the limits of the crater are. So that's the limit right there, and I highlighted it a little bit. Now you see all these lines running back and forth across the landscape here. These are section line roads, 1 mile apart. So that gives you an idea how big the crater actually is. These are 1 mile squares. So it's about 23 miles in diameter. Great big crater. And it's centered right north of this thing called the Calso Prairie. That's the only geologic or geographic landmark that I can point out for people to go see if they want to be at the center of the crater. Named after the town of Manson, which is near the center, and a lot of other little towns around it. It is the 25th largest known impact crater on Earth right now, until they discover some bigger ones. It'll probably get down on the list, but right now it's the 25th largest, and that's pretty seriously large. Okay, you say you've been up here in this area of the woods, and you haven't seen any craters like that. This is Highway 20. You might have driven in that area, and I don't think you've driven through a crater up there. It's actually not visible at the land surface, although it is at the rock surface. If you go up there now, this is what you see. This is my scenic overview of the Manson impact structure. It's very flat up there, and for a reason. This is the most recently glaciated part of Iowa, so rivers haven't had a chance to cut much relief up there. It's a very, very flat area. Here's a shaded relief map to show you just how flat this is compared to other areas of the state. Okay, we know it's a meteor crater because some of the rocks that were recovered in drilling from it had these features on it. This is a thin section. This is where you take a rock and you grind it down real thin. You glue it on a piece of glass, and then you grind it down to a few thousandths of an inch thick so you can see through it, and you can actually see right through all these individual minerals. And this is a quartz grain, this big yellow guy here. Now, normally a quartz grain would look something like this, but this has all these lines in it. These lines are called PDFs, or parallel deformation features. And when you see multiple sets of them going different directions, like the blue ones and the yellow ones here, that's considered by scientists as being definitive evidence of a meteor impact. You got that, you got a meteor impact. Those things form in a quartz grain when the shock wave from the exploding meteorite actually slides these quartz molecules along their crystallographic axes and melts it. So this is a little bit of melting between these things. So much pressure, it melts them. And in the case of Manson here, hydrothermal activity after the impact, hot water moving through it, etched out those melted zones and left behind a lot of little bubbles. So it makes it easy to see those. They're real easy to see the parallel deformation features at Manson. Well, it so happens that Manson's age is approximately the same age as the Cretaceous Tertiary boundary. And that's real important because there were a lot of extinctions when this was one of the big extinction events. 90% of all marine species disappeared in a relatively short period of time. 70% of all terrestrial species, most well known, the dinosaurs. So this little line there was the death of the dinosaurs. So Manson is about the right age to have been the crater to do that. So were we the crater that killed the dinosaurs? That idea got us a little monetary assistance from the U.S. Geological Survey. And the Iowa Survey and USGS Survey went out with this fine drill rig, and we drilled about 3,270 or 57 feet of drill core, the little cylindrical core of the rocks of the impact structure, and it really helped us understand a lot about it. These are an example of some of these cores and some of the various types of material, all related to the crater that we found. When we're done, we found out we had a complex impact structure. This is the cross section. If you just took a slice right through the middle of the crater, this is a cross section, and this is a crater from this here to there, the apparent crater. So what's a complex impact structure? We know what an impact crater looks like. This is Barringer Crater, or Meteor Crater in Arizona. It's about a mile across or so. Big hole in the ground, yeah. Well, a complex impact structure is a little different. Starts out like the Barringer Crater, starts out as a hole in the ground, but it's a lot bigger blast. When this meteorite hits, it hits with such velocity it explodes. And so when there's a big meteorite, you really get a big crater. When you get a big blast like that, not only does it blow a crater like that, it vaporized and melted and blasted material, but then it continues to grow. And the pressure from inside that thing pushes down so hard on the outside of the rock on the ground below it that the rock has nowhere to go, and so it ends up lifting up the edges. You get uplifted edges on the edge of that impact. When that energy dissipates, the edges collapse back down, and when they do that, they push up a little hill in the center, and this is the central peak. So this is an impact structure. This process of the side coming up and pushing back down and popping up a central peak is pretty analogous to what you see when a drop of water falls in a puddle. The physics is pretty similar. So this is the Manson impact structure as we have it on our geologic map here. We've identified 3 major areas of the crater, and they correspond to the cross-section like this. If we cut the cross-section through there again, the outer limits of the crater are out here. This area here is called the terrace terrain. That's the area of the crater that got lifted up on the very edges of the crater that was excavated there, and then collapsed back down as a bunch of blocks. And so this is a terrace terrain. In the center there, we see the uplifted central peak. And then the area between them, I call the crater moat, just because lots of times there's an impact like this on land, that'll be a low spot, so it'll fill in with water. It's like a moat around a castle. So we call that the crater moat. So those are the 3 terrains that we've mapped on our new geologic map. Now, one of the things that one of the reasons we drilled those holes, we were trying to find out what the true age of this is. And fortunately, we encountered this mineral here, sanidine. Sanidine is a feldspar, but it's a feldspar that forms from melted feldspar that's recrystallized. So the impact actually melted some of the feldspars in the rocks. They recrystallized to sanidine, and when that happened, it basically released all of the radioactive gases and then closed up around radioactive elements again, so it's like resetting the radioactive clock so we can get an age date on it. And so they use a procedure called argon 4039 to do that. Look at basically the amount of primary products of uranium that are there, and then the daughter products that are released by radioactivity and preserved within those crystals. They can look at that percentage and come up with an age, and this is what Glenn Isett from the U.S. Geological Survey did in 1993. And he came up with the age of 73.9 million years. 73.8 million years. Well, this is actually a little too old. 9 million years before the actual KT boundary, which was 65 million years. So Manson really didn't kill off all the dinosaurs. We can't claim to do that, although I always tell people that we did kill a lot of them. Now we've kind of refined that age a little bit, and we have 74.1 for the actual age of the Manson impact. Still about 9 million years before the actual KT impact. Well, people always ask me, what would happen if that meteorite hit again today? What would it be like? Well, here's the effects of the Manson impact when it blew up, if it would have blown up in the same spot today. There's a crater there, that little red dot. That's the Manson crater, about the right scale. Now, I've figured out what the effects would be by looking at an impact in Tunguska, Siberia, where a meteorite exploded over the landscape. It didn't hit, it exploded over the landscape, but it was the same type of huge amount of energy released to the landscape, and so you could see what things happened. And so trees were blown over away from this giant explosion. Trees were blown over away from the blast in Tunguska. And if we scale that up to a Manson size, well, I should say first, the electromagnetic pulse from the heat generated by the blast is going to set everything inside that yellow circle on fire. So basically, everything inside of there is going to be burned. Then the tree thing I was talking about, trees would be blown over as far away as Chicago, St. Louis, Ogallala, Duluth. That whole area would be devastated in there. And there was a trader who was riding his horse in the forests of Siberia that got knocked out by the shockwave, got knocked unconscious, fell off his horse. So the limits of that would be like Pittsburgh, Atlanta, Albuquerque, Salt Lake City. And you don't have to get too much closer than that to be dead. And so I just approximate about halfway. And we can guess that if the Manson thing hit in the same spot today, under the same conditions, probably most of the people between Columbus, Ohio, and Denver, Colorado would be killed. Well, it's kind of interesting to look at what the effects would be right here if that happened. See, here we are in Iowa City when that happened. Well, fortunately, there's a thing called an impact effects calculator that you can go online and plug all the information in, the size of the meteorite, how fast it was going, how far away it is, what angle, what kind of rocks, all that sort of thing. And I plugged it in for Iowa City. The blast wave would arrive, the big blast wave from the meteorite exploding would arrive at about 12.6 minutes. It would have hit with a pressure of about 11.6 pounds per square inch. Well, what is 11.6 pounds per square inch? If we look at a blast damage thing there, we see 10 pounds per square inch. Most all combustible materials were light and burned, so everything is going to be burned up. And a little bit more than that, 12 pounds per square inch, 98% fatality. So pretty much everybody's going to be killed right here in Iowa City if that hits. Not to mention 330 mile-an-hour winds, 98 decibel sound wave, masonry buildings collapse, wood frame buildings collapse and burn, glass windows shatter, 90% of the trees are blown down or stripped of leaves. Wouldn't be a very good time. Here's an aerial photo of Iowa City, and you are here, Iowa City Public Library. Well, let's just zoom out a little ways. Now, if that meteorite landed right on our heads right now, whoops, stop. We'll stop it right there on the land surface before it can explode. That's how big it would be. Here's the University Stadium out here, and City Park Bridge is right down there. There's a Highway 6 bridge down the south side of town. That'd be a big thing. And when that hit and exploded, holy mackerel, that would be a big blast. So let's just back up a little ways here and see what it would do. Here's a map of the area. That's the meteorite sitting right there. Everything within this circle here would be vaporized and blown into the stratosphere as vapor. Everything inside of this circle would be melted and thrown as molten material out with sufficient energy to probably carry it to most places on Earth. Everything inside of this circle is going to be busted up, pulverized, and thrown out of the crater. So that's going to be the actual hole in the ground. But in the meantime, the edges of that are going to be lifted up, and then they're going to collapse down. And so that's what the Manson crater is going to look like, sitting right on top of us. All the way up to Shoeyville, Oxford, down to Lone Tree, over to Springdale. So you can imagine a crater sitting there. That's what it would look like if it landed here. So that's a pretty exciting thing. And the 25th largest known on Earth. That actually, the Manson impact became a symbol of U-Haul the last time they did their super graphics for all the states. And here's what it looks like. They came up with this little illustration. There's my cross section with corn that's about 8 miles high for scale. Meteorites are zooming into about the right spot up there. Then they wanted an equation to make it look real simple, so I gave them that equation. That's a gauge equation for the ballistic trajectory of material that's thrown out of the crater based on the angle that it goes out and the velocity and the energy and all that kind of stuff. So when you see that coming down the road now, you know how it came about. Okay, one other one I want to talk about here before we quit tonight is the Decorah impact structure. This is a really new one. We just really found out about this about less than 10 years ago, I think. Here's a little diagram of the town of Decorah, upper Iowa River going through, and this area underneath here is actually a crater. So almost all the town of Decorah sits on top of an impact crater. We know this from looking at water wells in the area. One of the things the Iowa Survey does is it collects samples from water wells that are drilled all over. So we have all these water wells, and these ones in this area here around Decorah that are shown as green dots have a weird shale unit in it that's not found anywhere outside of the crater. If we draw a circle around those things, we find they all fit inside of that nice little area there, and that turns out to be the limits of the crater. We went through and remapped that area geologically in a little greater detail, and we found this. This is the rocks that we've encountered from the highest lying, the Maquoketa, the underlying Wise Lake, the Dunlite, Decorah, Platteville, St. Peter, the Winneshiek Shale, that's that shale inside the crater, and then Shakopee, Oneota, Jordan, et cetera, are older rocks. So the youngest rocks are up here at the top, these little pink guys here, and then they get older as you go north and east. And that's what happens there. And then when you get in the crater, you see we mapped this little area of Winneshiek Shale. This is that shale. It's only found inside the crater. And it's pretty weird. And it's not exposed very many places. It's only exposed in one place, right here. Come on, button. Right there. And it's barely exposed there. Everywhere else, that's nice soft rock. And so it's been eroded down by the river, and it's all covered with river sediment everywhere else, except for that one little spot right there. We know again that that's an impact structure because some of the wells that go into it have encountered this fractured rock. These are a couple of sand grains that are just shattered. And if we look at it under a microscope, we can see that there's multiple fracture sets going different directions. And we've had experts and meteor impact features look at these, and they've determined, yes, in fact, that is impact shocking. And then the classic shock features, the parallel deformation features, we also find a few of those. Here you see it in the corner of the sand grain. If we blow it up and look at it, those are multiple intersecting sets of shock lamellae. So definite impact, or definite proof of being a meteor impact feature. It's interesting because that meteorite impact is apparently the same size as a number of others around the world, including this is the AIM structure down in Oklahoma. There's Manson. Here's one in Wisconsin. Here's one up in the Slate Island, up in Lake Superior. And then there's also some over in the Baltic here. One over in the Baltic are pretty interesting, actually. They've actually recovered the meteorites from pieces of meteorite from out of the limestone that they fell into. So it's really pretty cool. So we know exactly what that is. Well, the U.S. Geological Survey has been looking at some other things up in northeast Iowa, and they did some geophysical surveying, which included an electrical survey to look at the resistivity of the rocks down below, looking for potential river channels, et cetera. And what they found over this area was this big, low resistivity area in the middle of the crater. This is a shale. Shale's got a lot of carbon in it, conducts electricity pretty easily compared to other rocks, and so it isn't a very resistant rock, so it's very low resistance. And that showed up so well in their survey that they made a big deal out of it because it showed their survey was working. So that actually proved the limits of the crater. The crater is a little weird. This is the way that it shows up based on our well data. We have one well right down the center here that tells us that there's rocks preserved underneath it. The Winneshiek Shale is this area right in here. So this is after the crater was formed and all of the breccia filled it and stuff. Then there was a hole in the ground that was filled in with lake material. Well, it isn't actually lake material. It's material from the ocean. So this was close enough to the ocean where somehow or other seawater got into it. Above that is a St. Peter sandstone that we know the age of the St. Peter, because that's a very famous sandstone that's spread all over the mid-continent, one of the most widespread geologic units in the United States, as a matter of fact. And we know it's 470 million years old, and it formed slightly after this shale, so that we know the age of the crater was about 470 million years. Well, here's the outcrop of the shale. You can kind of see a little bit of it in there in their bank. You know, some of our intrepid geologists doing their best. And there's a piece of it. This is Tom Marshall. That's Bob McKay back there, that little head. This is Derek Isles from Yale Peabody Museum, who's here to study these rocks, was there to study these rocks. Because one of the things we find in these rocks are these little compression fossils. These are carbon, basically, from a organic material that didn't have any preservable hard parts, just carbon, and they're left as little carbon films. And these are Eurypterids. Eurypterids are kind of sea scorpions. The oldest known sea scorpions on Earth were found right in there. They look something like this, and they got very big. Beside that, there was a variety of other types of fossils, all the way from shrimps to these things called conodonts, linguloblons, linguloid brachiopods, mollusks, all other sort of material found in there. So many well-preserved materials that this qualified as being a Lagerstätten, another one of those German words, but for really well-preserved materials. This is a little thing. The National Geographic came up here and did a program called Strange Truth, The Day the Sky Fell, and did a little story on that meteorite and how it ties into all the other ones. And for it, they built this little model of the Eurypterid. This is the size of the largest pieces that we found. So it would have been a 6-foot Eurypterid swimming around in the seas, a king of the seas in those times. So that's the 9 meteorites in Iowa's history. As I say, I'm sure there's more of them out there. I'd love for somebody to bring one in. If you think you found one, go bother Ryan Clark, at the Iowa Geological Survey. And if he thinks it's a meteorite, they actually have equipment that can analyze it to prove it. We don't have to just guess at it. So that's the end, and I'll be glad to entertain any questions. I've got a few rocks up here if you want to see some impact melt rocks and some rocks that were from the Manson meteorite. I don't have any meteorites per se. They're all up on the second floor there, but I invite you to go see them and invite you to come up.
Now, if you have questions, we need to do it through the microphone so the people watching on the live stream and the people who watch it later can hear your questions. So just raise your hand and I'll bring the mic.
Thank you. If you were to find a meteorite of sizable, like a baseball or bigger, what would be the value of that?
Well, it kind of depends. The value of a meteorite can depend on what kind it is or what provenance you have. Is there a story around it? Is it one of the Amana meteorites and it's a part of a whole story or something like that? But generally speaking, if you found one the size of a softball, I'm sure it would be worth several $1,000s. The thing to do, if you think you found one, the first test really that I always do is you see if it'll attract a magnet, if a magnet will be attracted to it. Not a super magnet, just an ordinary magnet.
Okay.
Because most meteorites, not all, most meteorites are magnetic to some degree or another. The iron ones are really magnetic, some of them, others are less magnetic. But there's plenty of other magnetic things floating around in the landscape of Iowa, so.
Right.
Any other questions?
How
about you guys?
Any
You have any
questions?
meteorites?
Any of you think you've ever found a meteorite?
Just a minute.
Here, hold. Let me bring you the microphone. You got to talk into this. It's okay.
Just so we can hear you.
So you said that comets leave trails of dust that the Earth might travel through.
Right.
What would happen if the comet directly collided with Earth?
Well, comets, are coming from a lot farther away than the asteroids, so they're going a lot faster. Asteroids travel about what? Maybe 3 or 4, 5 times the speed of a bullet. Comets travel 10 times faster than that. And because they're so fast, when they hit, they release a lot more energy. So even if they're only ice and a little bit of rock and not a solid iron thing, they're going to make a big boom. So when they hit, they really make a blast. We don't know for sure that we've ever been hit by a comet because, the materials all get dissipated and the ice is all gone. There's no pieces of comet material left. So you don't really know. But we have some craters that scientists think because of their size and their shape and things like that, they might have been comet impacts. But for sure, we've been hit with them. We just don't know.
Anybody else?
Any other questions?
Yeah, I want to know how you borrowed Up in our display case upstairs, there are meteorites from other museums. I want to know who he knows that would lend him meteorite. I mean, he brought these things to the library in a cardboard
Well,
box.
the secret isn't who I know. The secret is who knows me. Now, you live across from me. You wouldn't lend me a meteorite, you know, but those
Well-
museums, they don't know me. And I have a good gift for gab for that kind of thing. So
Well,
I'm going to see if I can get Tiffany's help for this next round, though.
There are some really neat, I mean, and some of these, I helped him load the display, and, you know, the rocks are this big, and they're heavy. And there's a piece of, what do you call it when the sand melts and turns to glass?
I have more than just meteorites out there. I have
Yeah.
other impact-related impact-related products. Tektites, which are melted pieces of earth from the heat when the meteorite hits and it splashes that glass out, you know, those are called tektites when you recover them. And I have some tektites out there, including one from a meteorite that exploded in the air above the Libyan desert, and it melted the desert sand, and so the glass is almost clear. It's really pretty cool.
It's
It's called
beautiful.
Libyan glass, and it's been used by the pharaohs as a part of their jewelry, et cetera.
I was just going to ask about what date the show was going to be in Cedar Rapids, the rock show.
It'll be in March 28th and 29th, I believe. It'll be a Saturday and Sunday. And we'll try to publicize the heck out of it, so.
We'll put posters up here for it.
It is a really nice rock show for those of you who haven't been there. It's the nicest rock show in the Midwest, really. You know, you'd have to go down to Kansas City one to top it, I think. We have a lot of dealers. We have a lot of materials. We have nice displays. We'll have a lot of different meteorite-type displays. I have got a friend with a shatter cone, which is when a meteorite hits and the shock wave goes out, it shatters the rocks, and sometimes if you go through the right material, it makes cone shapes. And I've got a shatter cone this big I'm going to try to get there on the display. Lots of neat stuff. You'll also see in the display upstairs a shatter cone. I put one up there. And then also there's some other interesting things. I had a little thing about the Sudbury impact. The second largest meteor crater on Earth is the Sudbury crater at Sudbury, Canada. And there's a big nickel mine associated with that. Well, that crater threw material. This was 1.8 billion years ago. That threw material all over North America, and the Minnesota Survey geologists have discovered it in the rocks exposed up in Minnesota. Material glass that was thrown out of that crater and stuff. And so there's several pieces of that Sudbury ejecta up there in the display case too. Pretty neat stuff.
And he's also got some stuff behind him on the table up here, and they are core samples from where?
These are from the Manson impact. That's that big impact in northwest Iowa. And I've got some samples of these were drilled down through the central peak, and so the central peak, when it comes up, pushes the crater floor up with it. And so the rocks at the top of the central peak are actually glassy material that was melted, totally melted. And you go a little farther down and you see them that weren't so melted. And then finally some rocks that were just broken up. So you're welcome to come up, take a look at these if you like. And again, I encourage you to go upstairs and check out the display up there.
And for those of you who came in late, anytime we have a anniversary, like the 50th anniversary of Apollo 11, they come out with a whole bunch of new books. Well, I rated the new bookshelf, and these are all the new space books that are checked in today. So I checked them out to me. If you want to check one out, you're welcome to. Just take it in and take it to the help desk, and they'll check it out to you. And do go up. You've got a little less than an hour before the library closes, so go up and explore the glass cases upstairs with all the meteorites. Thank you all for coming, and thank you, Ray. This
Hope
was a
to see
fun
you in March.
program.